Hello. So I start off talk on security, headers and cookies. So I'm not a .NET developer. I've done a little bit of Windows development, but not much. So what I'm going to be going over is concepts. Stuff about the headers, stuff about the cookies, what you need to set, why you should be setting it. What I can't tell you is how to do it. I can give you hints. If you've stuck with something, come and talk to me, and I can probably put you in touch with people who can help it, but I can't give you any specifics on this is how you set it in your particular language environment or whatever. And just say, I bought this clicker 7 years ago, and this is the second time I've remembered to bring it to an event. So, and it's working. I'm impressed. Right, so my name's Robin Woods. I run a site, digi.ninja. And I'm fairly active on Twitter as DigiNinja. So again, if you've got any questions or whatever, feel free to ask. Get in touch. I started my career as a desktop kind of developer, building some Java apps, that kind of thing. I then moved over to doing web stuff, but it was a mix of original VB, ASP, and then PHP. So I left the Microsoft environment before the .NET stuff kicked in. Moved into security testing in about 2009. The company I was working for, one of their websites got hacked. Me and the boss spent quite a long time going through the whole app line by line. Going, was it that? Was it that? Was it that? Really enjoyed it and slowly transitioned across. I'm a freelance tester. I've tested from everything from small local companies up to multinationals. I've done a couple of jobs actually in the Bank of England, testing their systems, various other banks, all different kind of sectors and things. I'm predominantly doing web app testing, but also bits of infrastructure and other things on the side. I've also published around about 50, maybe going up now, security tools and regularly blogging. So that's kind of my background on where I get sort of how I can talk about this kind of stuff. So we're going to start with HTTP headers. I assume everybody's aware of sort of what HTTP headers are, coming back from web servers. There's an example coming back from my server, from my site. So I'm not really a PowerShell person, but I learned this little command for this. So you've got a full bunch of headers there. Security, strict security, cache controls, and that's just an example of one set from my site. The main ones we're going to look at tonight are the key security ones. So it's these 8 that we're going to look at, and we're going to cover them in that order, starting with the longest name one, the X content type options. This was brought in about, I think it was IE8, and when they brought out IE8, it would, you sent down a file or a web page, browser would have a look at it and say, okay, you've said as a web server that this is a content type text. I'm going to look at it and go, well, actually, I think it's a PDF or I think it's an executable, so I'm going to serve it to the user as a PDF or an executable or something like that, which caused all sorts of problems. Because if you had a site where you could upload arbitrary content and then have users download it, but when it was downloaded, it was always forced to be, let's say, an image or a text file, because the browser would ignore what it was forcing it to be, you could throw malicious content at a user without them noticing it and without the actual site being complicit. So the site says upload me an image, you upload a PDF, it doesn't do its checking properly. When it comes down, the site says, here, this is an image. Browser looks at it and goes, well, that looks more like a PDF or an executable. I'm going to treat it as an executable and run it. And you get a lot of people were getting sort of owned and hacked and stuff through, or getting malware delivered through this mechanism where the browser was making its own decisions and saying, no web server, you don't really know what you're talking about. So this header was invented. X content type options. Only got one option or one parameter you can set on it called no sniff, and that basically tells the browser, no, shut up, I know what I'm talking about. This is a image. This is a PDF. Don't try and be smart. Don't look at MIME types. Just do what I'm telling you to do with it. So nice easy one to set, shouldn't affect any of your systems as long as you're serving the correct content types when you push them down. And so all the things I'm going to give a recommended option. So on this one, it's set it to no sniff, forget about it, shouldn't affect anything. And that's just how it would look if it came down as a header. Next one, XFrame Options. This specifies how, what is allowed to frame a website. So it can say, yes, it can be framed, no, it can't be framed, this is how it can frame it. Have people heard of an attack called clickjacking? Just put your hand up if you've heard of it. Some of you. Right, I've got a demo of it that I will run through just because people haven't heard of it. It's a nice one, and it should hopefully give you an idea of how it works and why this header's a good one. So hopefully I'm online. Right, come back. No, that's not going to work. This is where I've got to crane my neck round to see what I'm doing. But I built this little clickjacking demo. It's a social media system where if you want to close your account, fairly simple. Do you want to close your account? Let's just... Yes, I want to close the account. Click here to confirm. You're gone. So it's a two-step process. Close your account. Fairly easy. So with clickjacking. So I lure you to this page. It's on my site. It's, I don't know, win this prize, look at these pictures of kittens, do something that needs you to interact. Fairly simple. Click the numbers in order. So we'll click 1, we'll click 2, we'll click 999. Well done, you've won the prize. All looks fairly innocent. If I change the... let's just refresh this. And run it again, changing frame opacity. So what this has done, this is the concept of clickjacking. You have the site that you want to clickjack goes on top. You put it in an iframe, and then you set its transparency to 0, so you can't see it. Underneath, you put your pretty stuff. So in this example, on top, this bit up here, this box is the iframe containing the close the account options. Underneath that, you've got the game, click to win. So what happens as a victim, I come to the site, let's just turn that down a little bit, click the numbers in order to do a prize. So I click 1. What do I click next? 2. As you can see slightly in the background, your account's now been closed. I click 999, I get well done. Now what you would normally do as part of an attack is you would get rid of the iframe, you would clean it up, you would do some nice sort of tear down, so the user's never aware of what's actually happened on this site. But in the background, they've just closed their account. So this was originally used by people to do kind of bank transfers when it was a fairly simple system, when they didn't have all the two-factor or re-enter your password here to do this, where you could simply go, type in the money here, click this button and go. And people were using this system to basically steal money out of accounts. Stick a nice frame up on the top, nice frame behind, put the bank on the top of it, click a few buttons, bang, you've got the money. So this is clickjacking, and the reason it works is because the frame, the site itself, this one is allowed to be framed. There is nothing to stop this going in a frame. So this is where the XFrame Options comes in. You can use this to say the page is allowed to be framed from particular sites. So if you know that your content is always going to be framed by this one other system, great, you can say it could be framed by site ABC. You could say same origin, so you're allowed to frame your own content but nobody else can frame it, or usually you'd set deny. very few sites now use iframing for the majority of their stuff. So you would set XFrame options, the bottom option there, deny, or you set same origin or whatever you want. Deny, as I say, is the recommended one. I'll just comment on these first few options that we're going through. The options here are on a per page basis. So if I feed XFrame options deny down on login.aspx and then I don't feed it down on menu.aspx, ASPX can quite happily be framed. Same with the no sniff. If you put it on the login page, content won't be sniffed. If you don't put it on the menu page, content will be sniffed. So these are per page options. Normally what you do is obviously you just set it in the web server headers and that's it, you can forget about it. But it's just something to watch out for. You can't just simply set it on one particular page and then assume it will be, it'll be pushed out to every page on the system. So the next one, XSS Protection. The X prefix, the X hyphen, was set up when they had the initial set of headers that were defined and they were fixed. They were fixed in the RFCs years ago. People started adding these extra headers, so XSS protections and frame options and stuff. They weren't official RFC headers. So they started the policy of putting the X hyphen on the start of it. So if you see anything that's X hyphen, it isn't an official, or it wasn't an official at the time, header. It was something that somebody had made up, or a group had made up, and then it started to get adopted. Some got dropped, some got kept, but it's not part of the original RFCs. Some of them have now been made into RFCs and they are official and whatever, but just that's the history of the X hyphen. Main thing about this one, the XSS Protection, it's to enable or disable, if you wanted to, built-in cross-site scripting protections in your browser. At the moment, this only affects Chrome and IE/Edge. Mozilla Firefox doesn't have any built-in cross-site scripting protections. I keep hearing that they might be getting it, and at one point somebody said, oh yeah, it's fixed, it's set for a certain release. Then all that seemed to disappear. Talking about cross-site scripting, do people understand cross-site scripting? Yeah, show of hands if you do. Do we need a demo for that or not? Yeah, I'll give a quick demo of it since I've got it here. Where's my browser gone? Where's my cursor? So if you ever want to play about with web app vulnerabilities, really good product, for want of a better word, DVWA, Damn Vulnerable Web App. Originally written by a mate of mine, Ryan Dewhurst, it was part of his university project. And now there's 2 or 3 of us maintain it, and we add extra stuff every now and then. Let's log in and have a look. And basically it's got a whole ton of different web app vulnerabilities. So you've got fairly common SQL injection, blind SQL injection, cross-site scripting. I've recently added JavaScript, so that's attacking the client side rather than the server side. Password brute forcing, cross-site request forgery, all sorts of different vulnerabilities in there. There's also 4 different vulnerability levels: low, medium, hard, and impossible. Theoretically, impossible should have all the protection in place, shouldn't be able to bypass it, and low should be the easiest, but it does vary. And it's comical how often we get bug reports going, I just found a vulnerability in it. The help page is vulnerable to file injection or file inclusion. We go, yeah, it's a vulnerable app, but it's there. No, it's a vulnerable application, it's supposed to be. So as well as the published ones on the list, there are also a whole lot of other ones, sort of Easter eggs, I suppose, to find. But yeah, it's worth having to play with if you want to have a go with different attacks. Right, if I can see cross-site scripting reflected. So a very basic example, actually, no, first thing I need to do, yeah, that's set to low. If you ever come into this, the default security level is impossible, none of the attacks will work. You've got to remember to change this, otherwise you'll sit there banging your head against it going, I'm trying this thing, I've copied everything, it's exactly right, why is it not working? Because you forgot to change that from impossible. I've done that many times. So the basic idea of cross-site scripting is, what's your name? Robin. Hello, Robin. Yeah, it works. Basically, it reflects back what you put in. What if I put that? It's a bit hard to see, but that's now in bold. What's another tag? Is you underlined? Yeah. I can't even spell my own name. There we go. So it's not encoding any HTML characters. So the attack from this is Robin, and then let's put some JavaScript in. So script. And as it's echoed back, the script tag's been written into the page, alert box come up. Most people demo XSS with a fairly simple alert box. People sit there going, oh wow, you managed to pop up an alert box on a machine. Oh wow, so what? Proper proof of concepts for this, the one I really like doing is rewriting the page to look like your login form, but to send the contents off to my server. So it's very easy. Once you've got script in there, you can do whatever you want. You've got full access to the DOM. So it would be, I can never remember this stuff off the top of my head. Is that about right? No. But basically you would do that kind of thing. Start rewriting the page. You can drop keyloggers on, you can steal content, you can port scan internal networks. If you want to get into this stuff, look up a thing called Beef, Browser Exploitation Framework. Amazing what that will do with cross-site scripting. But anyway, that's cross-site scripting. And that's what the header that's what the XSS Protection header will protect you against. It will force the browser to enable the protections, even though they are all enabled by default in most browsers that I've seen. Well, Firefox and Chrome and IE, they are disabled by default, but this will force it in case for some reason the next release Microsoft go, actually we're going to disable it by default. Setting this, it's belt and braces, it makes sure it's definitely set on. Options for this one, you've got 0 to disable it. I've never seen this used, but if you ever do need to disable this for some reason, pass it 0. 1 turns it on and sanitizes the output, so it will still get written in, but the browser will attempt to tidy it up for you. The common one, the bottom one mode block, will turn it on and it will block any malicious content. It will say, I've seen JavaScript coming through that's coming from a user, I'm not going to let it run. And if you look in your developer console, you'll see a line that says blocked content. So that's the most common one. The reporting URI, report one there. I'll come on to what report URI is later, but it basically lets you send out reports to say, or lets the browser send out reports to say, hey, I think I've been attacked. And that's a nice one if you've got time to monitor it and you've got somebody who will actually look at the logs. And you've got a site that's not going to just fill your logs because people are attacking it all the time. There you go, a couple of examples of setting that. Referral Policy, as it says, it's the newest header on the block. It was introduced, I want to say, back end of last year kind of time. It basically specifies when a browser can pass the referrer with a single R header. So for those who don't know the way it works, if you browse to my site or browse to a page on my site, you click a link. When your browser sends the request to the next site, it will also send in that request a referrer header that says this request came from, and it will give my site. And it's really good for sort of tracking where your people came from. So you can look at the referrers and say, okay, onto my home page, I got 3 clicks from the BBC website, I got 4 clicks from ITV, and I got a couple of clicks from .NET Sheffield. And you can see where things come in. The problem comes if you've got a site that's particularly heavy in query string parameters that leak important information. So you should never have things like session IDs on query strings, but people do. I've tested for a bank that query string has got session ID in it, and if I can get a copy of that, that's it, I've got full access to your account. The developers are going, no, no, you'll never do that, you'll never be able to steal it. Well, what about proxy logs? What about these logs? What about that? Oh, no, no, you'll be fine. But that HTTP referrer, you're on the bank site, you click a link that goes off the bank site onto another site, the referrer header has got that full query string in it. So it's got the session ID. If somebody's malicious on that external site, they pull that out of their logs, bang, they've got full access to your account. So this was realised, and the referrer policy header was created. You notice it's not got the X in front of it. It is an official one that's created by W3C and Mozilla and the Google crew. So yeah, it specifies when you can pass things over. So I will try and remember these. You've basically got no referrer, referrer header never gets passed. No referrer when downgrade. So if you're an HTTPS site and you're passing across to an HTTP one, a referrer won't be passed. But if it's HTTPS to HTTPS, then referrer will be passed. HTTP to HTTP it will. So it's basically on a security downgrade. Origin is, it will pass just the domain part of it. So this is where if you've got vulnerable things in your query strings, Origin is a good option because it will only pass site.com or whatever. It won't pass site.com/really vulnerable page, $ID equals all your bad stuff. So Origin's a useful one, or a useful part of it. Origin when cross-origin is if it's going from one domain to another, it will only pass the origin, but internally on your own site, it will pass everything. So if you rely on the query string of the referrer for some reason, then use that one, and when it goes outside, then it's safe, you just get the domain. Little story on that, I did test a system once where you went to the login page, you logged in, and it did a full login process. It properly checked your username and password. It then redirected you to the menu page. The menu page checked the referrer header and said, did I get referred from the login page? If I did, then fine, you can access it. Otherwise, no, get back to the login page. It didn't check the session, it didn't check whether you'd actually logged in or not. All it checked was, did you get here from the login page? Now, obviously, it's very easy to spoof headers. It's very easy to put your own in. And so all I did is, yeah, okay, throw in an extra referrer header, request the menu page, and yeah, that's it, I was into the system. So never rely on these headers. They can always be spoofed. Useful for internal tracking, useful for stuff like that, but please, certainly don't make security based on it, but yeah, just don't rely on it. Always assume it's tainted, malicious, the user can modify it. Same origin is it will pass in the same origin, but it doesn't matter whether it's HTTP or HTTPS. So if you refer from HTTPS site.com down to HTTP site.com, it will pass. Strict origin will be only if you're on HTTPS.com, HTTPS site.com. It will stay within that, but it won't if you downgrade. Strict origin when cross-origin. I've got to read this one because I can never remember what it is. This is the recommended one. It's basically an amalgamation of everything, making it more secure. It is, if you go outside your domain, then it will only pass the domain part of it, and only if you're not downgrading security. So as long as you're staying on HTTPS, you're fine. As long as you stay on HTTP, you're fine. If you downgrade HTTPS to HTTP, it won't pass it. It won't pass any query strings. Basically, it does everything that you'd kind of want if you've thought about all the rest of them. So that's the recommended one. Final one, unsafe URL. I don't care. Everybody can have my referrer. Just take it. Don't care. So a couple of examples. And just be careful with that. It can break certain logging apps. Things like, I Google Analytics, but not Google Analytics because they do it much better. But some of the cheaper end tracking systems will rely on referrers to work out where things are going around the system. And obviously, if you're on referrer programs that rely on the referrer header, again, it could break those. So most apps, don't worry about it, you can set it. Some apps, you will know if you're using referrers for anything specific. If you are, then just think about what you're passing and when you can pass it, when you need to pass it. Right, up to this point, I say, everything has been per page. This is the first one that is for the site. Strict Transport Security, also known as HSTS, HTTP Strict Transport Security. What this one does is it enforces HTTPS on all your traffic. A couple of different options for it when you set it. You can specify a maximum age, so you could say for the next day, for the next week, recommended option is for the next year. Enforce all my traffic to come over HTTPS. Obviously, it's a good thing because we're wanting to encrypt traffic now. Google is giving better page rankings for encrypted traffic. I'm going to say paranoid people. A lot of people are worried about security and about their stuff going clear text over networks. This just basically enforces everything on this website will be encrypted. And yeah, it sets it. Middle option, you can specify a maximum age and you can say include subdomains. So this will enforce it for site.com and test.site.com and whatever. It's just a way that you know your entire system, all your domains, all your subdomains will be covered if you set that. Again, watch out if you're setting, or it's important, watch out if you're setting this, make sure you know what your environment's like. Make sure you haven't got a little part of your site that relies on being HTTP. Make sure you haven't got subdomains that rely on HTTP. I've seen this with marketing have spun up their little click here to win a prize site that they've just thrown up on a subdomain that somehow they managed to sneak through IT without you noticing, and that's running completely over HTTP. Security team have set this, set include subdomains. All of a sudden, that little marketing site disappears because the browser says you've got to access it over HTTPS. Go to it over HTTPS. No, it's not there. You haven't got a certificate. You've not turned it on for HTTPS. It's dead. So it's a really good setting, but you've got to be sure what you're doing for it. And I said, once you've set this header, that is it for the browser. It's not a per page thing. It's for the site or for all the subdomains for the site as well. So make sure you know what you're doing with it. And I'll mention the preload option in a minute. So top one's an example of setting it. That's you set it for a year and all the includes it for your subdomains. If you want to turn this off, you can do. That's the bottom option. You set it to 0. That must be served over an HTTPS connection. So if you realise you've messed it up and for some reason you can't serve HTTPS, setting that won't really help you because you can't serve HTTPS to serve the thing to say I'm no longer serving over HTTPS. So yes, you can use this. Maybe if for some reason you are downgrading your system, you can use this to set it and to kill the HTTPS. But again, I've never seen that used. This is there's still a vulnerability with this, and the problem comes on that first click. So most people, if you tell them to go to site.com, they won't type https://site.com. They will type site.com, which for now and for the foreseeable future will default to HTTP. So on that very first browse, before the headers have been sent, that first browse, that first connection will go over HTTP. If an attacker can get in the middle for that first connection, can strip that HSTS header, then they can stop you ever seeing it. If your browser never sees it, your browser's never forced to go over HTTPS. And at that point, you've got man in the middle, you've got all sorts of different downgrade type attacks. So that first one click, first browse is always potentially vulnerable to this. 99.99% of the time, it doesn't matter. You'll be doing it at home. Nobody's going to be intercepting your traffic. You've got it logged into your browser, then after that first one, that's it, you're secure wherever you go. You can't downgrade it. That's the other thing with this, is if you browse to a site that's got this and it has been downgraded for some reason, like somebody's man-in-the-middling it, or somebody fiddles with the certificates, certainly Chrome will put up a warning that can't be bypassed, or can't easily be bypassed, that will say, HSTS enabled, tough luck, you are not going to HTTP version site, we are stopping you. So it is, with invalid certificates and stuff, you've still got the option to click through, say, no, I know what I'm doing, advanced, yes, accept it. HSTS, once that's on, you can't click through it and accept it. So to get around this first click thing, there's a system called preloading. What that is you go to this preload site and you say, I always want my site to be HTTPS. I know what I'm doing, I've set it up properly, and that's it, I want to be. And what will happen is the browsers will bake into them that setting to say this site is only HTTPS. Then even on your first click, it's built in, it's hard-coded. The browser will take over and say, you didn't type HTTPS, but that's where you're going to. So it will force HTTPS on your first access. Only really applicable to hardcore sites that need security. So things like banks or anywhere else that you really want to force users into it. If you get this wrong, that browser is forcing everyone into HTTPS. There is no way to undo it. Even if you set the 0, it's still baked into the browser. You're tied in. You then have to wait to the next version of the browser to come out that's removed your entry. So again, HSTS, only set it if you know what you're doing, only preload if you really know what you're doing and really need it. I'm just going back a couple of slides. Where's it gone? That's what the preload option's for. So you would set a header, you'd set your max age at, I think it's got to be a minimum of 12 months, and you would specify the preload flag. And you've got to specify the preload flag because that stops me going on and telling Chrome to preload your website. Otherwise, I just go on and say, yeah, all these sites I don't like, stick them into Google for preloading, into Chrome for preloading, and then they've had it. So you've got to set, I think it's at least a minimum age of 12 months, and you've got to set the preload flag for it to be accepted. And once you've submitted, is my cursor going to work? Nope. Once you've submitted through there, Chrome picks it up off the HSTS lists and, as I said, bakes it in. If I can, this is what it looks like. So there's a bunch of Google domains, obviously, because this is Chrome's source. So Google pins all its, I can see Poland there and various others. And then we get down to what users have submitted. So ApolloAuto.com, whoever they are, they wanted to be preloaded. IRC Cloud, Neonisty.com. And these are all people who've just gone in and said, yeah, I want to be preloaded. And this is hard-coded into the Chrome source. There you go, these are the ones with the include subdomains as well. And might be interesting to go through a few of those and just have a look why they are so paranoid about security that they need to be preloaded. But Google build this list, Mozilla for Firefox then scrape this list and use it in Firefox. So it should always be Firefox and Chrome are in sync. I have no idea what IE do, but that's Chrome and Firefox. HSTSpreload.org is where you go in to say you want to preload it. Right, content security policy. This is the hardest one to implement. Getting this wrong can completely kill your site. Getting it right, I think, can make a site and a system a lot easier to look after, a lot easier to maintain. The idea is it locks down what resources can be pulled in from where and how they can be used. So it can specify things like you can bring this script in locally, you're not allowed any inline CSS, you can pull images from this site, you can be framed. It does replace to some degree the XFrame options by saying what can frame this site. It also says what sites this site can frame. So there's a lot of settings in it. It's got two modes, enabled and report only. mention report only again in a minute. Top example there, default source, HTTPS. So what that says is you can pull in any content you want into the site as long as it's over HTTPS. So no non-secure traffic. You could say, I don't care which, whether it's HTTPS or HTTP, as long as it comes from site.com. You could say it's got to come from HTTPS site.com. So you can sort of get granular like that on it. But it's not just that simple. You can start saying, well, I've got no default policy, so by default everything's blocked. Well, yeah, that's one of the things. Everything is blocked by default unless you actually enable it. So everything's blocked by default. You can pull scripts from site.com, so HTTPS site.com, so you can't pull them from your non-secure version. You can pull style sheets from your HTTPS site and from your images site. So you start building up lists of where stuff can come from, where it can't come from. And what this does is it stops people injecting malicious content into your site. One of the big things it stops is cross-site scripting, because most cross-site scripting is it will drop the content into the page. So the reflective one I showed you before, it wrote in, hello, your name is, and then my angle bracket script tag, whatever. That was written into the page. By content security policy, you could say you're not allowed inline CSS, inline scripting, so that will kill it completely. Same for if you know stored cross-site scripting, it will kill that because that is also inline stuff. You can stop, when I've not managed to get cross-site scripting, but I've managed to get HTML injection, I've rewritten pages using just style sheets and pulling in images from here and there, and sort of rewritten stuff like that. Again, it kills all that off because you can't pull in third-party style sheets or third-party images without them being explicitly set in the list. These are the different things you can set. So you can say, I don't know some of what these do, but you can guess most of them. Child source is what you can frame, I think it is. Font is where you can pull fonts from. Forms, where you can post forms back to. So if you're on a login page, you want to set the form action to only be able to post back to the login page. Sounds fairly obvious, but if I can intercept it and somehow and get that login form posted off to my site, I've just stolen your credentials. So you can lock that down. Frame source, images, where you can pull stuff from, what media types you can have, what plugin types this site can enable, scripts, style sheets. Report URI, again, I'll mention that in a minute. And this very complicated sheet that you won't be able to read from where you are specifies which of these headers, which of these, and a whole load others are available in which different browsers. So the beautiful IE doesn't support content security policy. Opera from certain versions onwards, and you've got sort of Chrome and Firefox supporting things. I think that one there, the second one in, is Edge, in which case Edge does start to support things, but IE never did. And you've got your mobile browsers as well, which are different. They implement different features from different versions. So implementing this, it's really good if you can do it. If you're going to do it from the start of a project, because it forces you to put all your JavaScript in libraries, all your CSS in libraries, all your images are coming from this image server. It really forces you to split everything up and think about it and build sites properly because they're all broken down. It stops that little hack where that style sheet is made, or that thing is styled up slightly different to everything else because Fred over here put a little tweak in to fix that in IE because it didn't work with this. It stops all of that. But at the same time, implementing it and actually thinking about it is a real pain. Even putting it on my fairly static site, I killed quite a bit of stuff because I had dropped in the odd little CSS tweak or a little script to hide and show dialogues. So implement it on an existing site, yeah, good luck on it. From a new site, I would definitely consider it. And make sure you get it on all the developers, all the development servers as well, not just on your production one. Because what you don't want is for it to work on development, push it up to production, and then suddenly the CSP kick in, and why is that not quite working? Where's that scroll bar gone? Why is that image disappeared? The good thing about it, if you bring up your browser developer console, it will log exactly what's happening in there so you can see why things aren't working. Yeah, this is where we come back to the report URI bit of it. You can set content security policy, if you're just developing it, to log stuff. And back to the other ones where I mentioned report URI, the XSS Protection, and I'll come on to another one in a minute that uses it. You can say report URI and then a URL, and the browsers will send out this. I've just had a failure for this. So I've just tried to load an image from a source where I'm not supposed to, or I've just tried to run inline script I'm not allowed to, and it will report it all out. And if you monitor those logs, then you can see how you're doing with it. You can see where you've broken things. You can see where people are trying to attack you. Oh yeah, look, somebody's dropped in a thing to try and pull JavaScript file off this server. And then maybe you look at it and see how they were trying to attack you or why they were trying to attack you. So yes, that's dropped in. I would strongly recommend setting up an account with a company. They are now reporturi.com. Full disclosure, it's a mate of mine that runs this, but it's a really good service, particularly for your content security policy. The browser just sends off a whole ton. Every time, for some reason, it's triggered, it sends off an alert. It is a little bit overwhelming, I suppose is a good way to put it, at the start, because you get a lot of stuff, particularly where things like ad blockers have kicked in, and ad blockers have injected script into the page to try and do things, or various extensions inject stuff into the page, and you get a load of reports for them, which are kind of false positives, but you still have to dig through them. Once you get used to your site, same as any logging, you'll be able to sort of filter out all the cruff, and you'll see the good stuff, and you're like, actually there I have missed it. And this is an example of my site. I chucked a new font file on there a while ago. I forgot to update my policy, and when I looked in report URI, I got it's the standard thing, the date it happened. I'm on enforcing, so I am saying it's locked down. It will enforce the policy. Your other option is just to report. So if you tell it to just report, the browser will allow it through, but it will log all this data. So it's enforced on that particular page. The directive was the font source, and this is the report, and you can scroll that out, and it basically tells you, off my site, I'd thrown a font source in, and I hadn't told it was allowed to use that font. So the site was never showing the font. Worked fine on my development machine. I put it up, forgot to check it, and it starts reporting it. So even on little sites, it's quite easy to get it wrong and mess up. But if you turn reporting on and you monitor it, which is the really important bit, you've got to monitor it, then you can pick up all these issues as they're happening and fix them. And once you've got things flowing, you can kind of forget about it because it's there and it just works in the background. Public key pinning. Jamie run off, or is he somewhere in here? Jamie asked me about this when we came in. Short version of public key pinning is that it's a way in a header to say this website can, back a second, CSP is on a per page basis. This is back to on a per site basis. So this says to the browser, these are the signatures of the certificate authorities that are allowed to sign certificates for this site. So on my site, I would say that all my certificates have to be signed by Let's Encrypt. Komodo can't sign one, Semantic can't sign one, it can only be Let's Encrypt. The idea is that if a CA goes rogue or gets hacked like Semantic did last year, and they start issuing random certificates that they're not supposed to, it doesn't matter, because they would have to, for me, they would have to pop Let's Encrypt to get fake certificates. If they put a Semantic one on, it wouldn't work, because I've told them this is the signature of Let's Encrypt, it's got to do that. Long version of it, it is a bit more complicated than that. You've got to have sort of multiple redundancies and all sorts of things, but don't worry about it, because the general advice is don't do it. Don't use public key pinning. To the point that Google, who were part of the team that created it, have now dropped it, or will have dropped it from Chrome 67. And the big problem was what's been known as PKP Suicide. People set these signatures, they say the certificate can only be signed by such body, and this header lasts for 12 months, which is the standard thing. So for the next 12 months, my certificates can only be signed by Let's Encrypt. And then they mess something up and they shift the certificates across to some Semantic or Komodo, and then all the browsers that are set, that have had the headers, suddenly can't access the site. And it goes a little bit more in depth than that, but basically you could really screw yourself up by setting this wrong and lock everybody out of your site. That's the link. It was Smash Magazine, I think, is the big public one where it happened to, and they did a good write-up on this is what happened, this is where it went wrong, this is how we cocked it up. Certificate expired, we renewed it, we forgot to change the headers first. Because the certificate expired, they couldn't put that one back on because it was expired, so that would be ignored, and whatever, read the story. There is also a fairly local bank that also did this, and they locked about 50% of their users out by just messing up the pinning. Anybody who come to the site up to this point had the signatures for the old certificate in, they suddenly couldn't access the site. Anybody new were fine, because they got the new keys, the new signatures, they could access it. Anybody older couldn't. And generally the only way to fix this is for the browsers to build in a patch for it. Or you somehow go talk to all your users and it's a big nasty thing to try and fix it. But basically it's a browser fix. Chrome, you have to talk to Chrome very nicely, or Google and Mozilla. Yeah, that's the link for it. Smashing Magazine. There is also the thing of if I manage to get control of your server, I pin keys to some Chinese post office who are a dodgy CA, and then I give you your server back, and suddenly I've forced you to use the Chinese post office to issue all your certificates. Otherwise, again, all your users are locked out. So there's also that side of it, which is more a malicious attack side, but it's the accidental getting this wrong that's more worrying for most people. But it's been replaced by a thing called XPEC-CT. So XPEC-CT is short for Expect Certificate Transparency. And what this is now any certificate that's issued by certain the major certificate vendors will be logged in certificate transparency logs. And there are various sites out there that are doing this. And basically it says, have I got an example? No. It gives a log of this certificate was issued by this group at this time, and this is a bit of information about the certificate signing request. And the logs are completely public, they're fully searchable, and the idea being that you set up monitors for your domains and you monitor them to say who to look for any certificates being issued. Certificate issued this morning, IT department, who requested certificate? Yeah, I did. Okay, valid. Certificate got issued this afternoon. Did anybody request it? No. Right, we've got a rogue certificate out there. We've got to deal with it. And you can sort of put things in place. It gives you alerts that rogue things are happening, that people are attacking your certificates, but it doesn't kill your users if you get it wrong. So this is basically the replacement for it. You've got a couple of options. You've got enforce, so you can specify only accept the certificate if it appears in a transparency log. So again, if it's somehow issued by internal and you manage to force internal CA certificates onto a browser and you do all this, that and the other as a corporate man in the middle, it will still get killed because that certificate will never appear on an official certificate transparency log. So this can be used to kill monitoring on companies that are doing inspection at the border. So they're putting their own CAs onto machines, so it will stop that. You've also got your max age and your report URI. So again, this can get logged out to any server, reporturi.com being the better one, and you just sit and monitor that. Another one to monitor it with is Facebook. For some reason, Facebook have built a brilliant little app, I suppose, that you just go on and say, these are my domains, monitor it. And they will send you updates whenever a certificate's issued for your domain. And it seems so weird that it's Facebook that's doing it, but they've decided that it's really important and they've gone with it. There you go, there's a couple of options, max age 0 and report. That's if you're testing it out, and then you can set your ages. The higher, the 60 seconds is just a basic one if you're just playing with it, but you push it up to a year or whatever if you're doing it in real world. Yeah, top one is a link to a set of logs where you can actually go and view the logs, and the bottom one's Google's notes on how to get it set up and how to monitor it. I'll make all these slides available somewhere later, and obviously you've got the recordings for it. Oh yeah, there you go. I thought I'd put a slide in. So this is an example. This is from me, from my site. Back in 2015, I was using GoDaddy for my certificates. And obviously back then, they'd started doing certificate transparency. In January 2016, I changed to Let's Encrypt. If you have a look, 3 there on the same day. That's when I was experimenting with it, setting it up. And then I messed about with it a bit more, and then you start getting your regular updates. So January, February, March, April, July, October, December, and it goes through. So you can see Let's Encrypt. The certificates are only valid for 60 days or 90 days. I think it's 90 days. So if you look through that, you can see the renewal every 90 days. And you will expect it. So you look at it and go, yeah, that's our 90-day renewal. Don't worry about it. Oh, that's come in at 30 days and it's by GoDaddy, but we normally have it by Let's Encrypt. Something's going on here. Check it out. Downside to this is this leaks all your domains that you've got certificates for. So I was looking at this last night, and literally there are domains being registered like 10, 20 a second. I asked for a list of everything. It just scrolled like mad. You couldn't read it. So every domain, every subdomain that's getting a certificate issued, it's ending up in these logs. So if you've got something really sensitive and you've put a SSL certificate on it, it will get logged. So if you need to do that, I would look at getting a wildcard certificate. As attackers, we like to look at that for spotting select new brands. So if Cadbury's are coming out with a new chocolate bar, and we're kind of trying to guess the name of it, and we suddenly see wonkaelite.cadburys.com, well, we've just got the name of the new bar, and we've got access to the site potentially before it's been launched. So we can go and look at it a couple of days early and buy shares or do whatever we want to do on it. Set up our click fraud campaigns to steal stuff and get in with Google and whatever. So it's really good from a security point of view, bad from a kind of company privacy point of view, but you just got to know that it's there and be aware that potentially you're leaking out information through it. Right, that's the headers done. I can smell the pizza at the back. I'm going to go quickly through cookies because you probably know about the cookies already, but I wasn't sure how long it takes, so I threw them in anyway. Again, for a quick example, hard to see on the screen, but there's a few cookies being set and pulled back from a nice bit of PowerShell. 3 main flags you can set on a cookie. You've got secure, HTTP only, and same site. Secure, very simple, says this cookie will only be passed back if you're running over HTTPS. Stops cookie from being sniffed by going over HTTP. Really good for session cookies, stuff like that, particularly if your users are on hotspots at airports and stuff. It stops session hijacking, stealing accounts. And session hijacking is real. I have sat in airports and watched sessions going backwards and forwards, and the guy next to me has stolen all the sessions and watched stuff that he's not supposed to. Yeah, so it should be set on all session cookies. And yeah, if you say, oh, we haven't got an HTTP version of our site, there's no port 80 listening. If I do http://site.com:443, that's say use HTTP to connect to 443. Browser will make that connection, it will send the cookie. Yeah, you'll get rubbish back because the website will say, hang on, you're trying to talk not unencrypt to an encrypted site. But because you've specified HTTP, the browser will send the cookie over HTTP. So don't assume that you don't need it if you don't run an HTTP version of the site. HTTP only, fairly simple cookie, just says JavaScript's not allowed to touch the cookie. Really good for stopping session hijacking by cross-site scripting. So normal cross-site scripting would pull the cookie out to the DOM and throw it out to an external site. You've then got access to the session. HTTP only says JavaScript can't touch that cookie. It can't be grabbed, can't be sent out again. And really, you should never be needing session cookies accessible by JavaScript. But just be careful, have a think about your app first before you set it, just in case. Finally, the new one, same site. This was introduced back end of last year. Again, it's not supporting IE, Edge, Safari. I was told Opera supported it, but then another site I looked at said it didn't. I don't know. Basically what it does is it stops an attack called cross-site request forgery. Cross-site request forgery, the best way to describe it is I can trick your browser into doing requests on for me, but without you realizing what you're doing. So if you want a proper explanation of it, grab me later. I will quite happily explain it properly. But basically, it kills the same site cookie. Says if I send a request in, that's the best way to describe that. If I try and get your browser to do a request, because it's my site that's initializing it, it will see the kind of the referrer model in the browser and it won't send the cookie with it. If it's you that's doing it, it will. It's a tricky one to understand, but once you get your head around it, it does work. Two options for it, strict and lax. Lax is the better option because it's strict. The first time you visit a site, you won't get cookies. So if you've logged into Facebook and then you close your browser, bring it back up again, put facebook.com in, because it's not coming from the same site, the referrer isn't facebook.com, it's nothing because you just open a new tab, a new browser, the cookie won't get sent. So the first time you go to Facebook, if you're in strict mode, you won't be logged in. If you refresh, yeah, you've come from Facebook, you've gone back into Facebook, the cookie will be sent and you'll be logged in. So it's lax is generally the better option unless you know what you're doing, unless you really know your site. And lax will also say it works because the way it sends stuff through. And that's about it. Sorry the cookies bit was a bit rushed, but I think pizza's probably a bit more important than cookies at the moment. Anybody got any questions on it?
Do you have the .NET vulnerabilities as well?
It's a PHP app, so no it doesn't. There is Acme Bank, ACME Bank is, I think that's the .NET one. Yeah, something nodding there. By a group called Foundstone. So if you want to have a look, Foundstone do Acme Bank, Acme Casino, Acme, all sorts of things. They're all in different languages. I know there's PHP, there's .NET, there's a Ruby one. You name it, they've got one. They've got them. Another one to play with is Mutilidae, named after a wasp that's set up. That's more in a kind of competition style. Do this, solve the problem. Get the result that you're expecting, well done, you've got a tick in the box, move on to the next one.
What's your take on responsible disclosure and security.txt?
Security.txt, for those who don't know, it's where you're supposed to put your contact information for security issues. So if somebody finds vulnerability on your site or somebody wants to get in touch with you, that should have all your contact details in, stuff like PGP keys to encrypt things. They're good to have because there's so many times you try and report vulnerabilities and the sites, but the companies just don't care, they don't have an email address, there's no way to report anything to them, things just disappear. Responsible disclosure, it's hard. It all depends on the company. I've reported stuff to companies and they've been brilliant, we'll take it, thank you very much, we'll fix it, we care, we'll work with you, we'll do the whole lot. I've reported other stuff that's just gone, whoosh, disappeared.
Anybody tried to sue you?
No, I've not reported that much, luckily. I know people who they've tried. It's kind of, you do it in the right way, you look at the company first. If you're not sure, there are agencies you can go through. People like BugCrowd or HackerOne. Basically, BugCrowd and HackerOne do bug bounty programs. So they will act as an intermediary between you as a tester, hacker, attacker, whatever, and a company. And generally, the way they normally operate is the company comes to them, says, we'd like to do a bug bounty. These are the rules of engagement. Anybody can try and hack our site as long as they abide by these conditions. You as an attacker or tester then go, test it, you submit your issues, and hopefully if you get one right, they pay out to you. That's the normal model of it. So it gives the company free-ish testing until there's an issue found, and then they pay out on the issue. So it's constant testing because people are playing bug bounties all the time. What you can do with them as well is if you find a vulnerability on a site and you don't want to talk direct to the end company, you could generally talk to BugCrowd and say, look, I found this, could you mediate it for me? I want my name kept out of it. and generally they will help you with stuff like that. Just dropping vulnerability straight on the web, I think it's generally a bad thing to do, but there have been times when it's happened because the researchers have been so frustrated. It's been 12 months, they've tried everything possible, they've talked to the company, it's a blooming big open hole that anybody can walk through, anybody can steal the data, and they just get so fed up, it's like, oh, just dump it online, here's the vulnerability, and now you're embarrassed, fix it, or get your data stolen, and it's there. So there are times where just dropping 0 days, dropping vulnerabilities is kind of okay, but usually I think it's worth going through the right channels first to try and do it. Anything else? No? Right, there we go.